So number 24, the length of a rectangle is 6 inches more than the width, and the perimeter of the rectangle is 52 inches. Find the width of the rectangle. You have a word problem, you should draw a picture. So I'm going to draw my rectangle. The length is 6 more than the width. So I have width here, W. The length would be this side, and we know that it's equal to W plus 6. I'm actually going to use W plus 6 for the length. The perimeter is 52 inches. We want to find the width. Perimeter is distance around. We're just going to add up the sides. So this side would also be W. This would be W plus 6. And so we're going to use W plus 6 plus our W plus another W plus 6 equals 52. And combine like terms. I'm going to add the W's up. I have 1, 2, 3, 4 W plus 12 equals 52. Subtract 12 from both sides would be 40. Divide by 4, W equals 10 inches, which is A. We're going to skip number 25 and go to number 26. 25 is a regression problem, so you have to have those handheld graphing calculators. That's why we're not going to do that one. Number 6 is a log base 5 of x minus 9 equals negative 1, and we want to solve for x. You just change your log to exponential form, and you do that by basically just switching the x minus 9 and the negative 1. That's how you write it exponentially. So that I still have base 5, but I have it in exponential form. Base 5 of negative 1 is equal to x minus 9, and then you just solve that equation. 5 to the negative first would be 1/5. That negative on an exponent just means reciprocal. It doesn't mean negative 5. Add 9. So if I add 9 to 1/5, that's 9 and 1/5. Our answers are in decimal form though, so that's going to be x equals 9.2, which is C. All right, number 27, describe how to transform the graph of the basic function g of x to the graph of the given function f of x. So we've got our basic function, that's what we're going to start with. It's a natural log of x, and we want to know how did we go from the natural log of x, or what happens to our graph when we go from the natural log of x to f of x, which is the natural log of negative x plus 5. You just want to kind of follow the order of operations. We've got that negative x is in parentheses, so that's the thing that happened first. Anytime you put a negative on just the x, it obviously changes the x coordinate, so that's going to be a reflection across the y-axis. That's what this does. That would be the first thing that happens. Reflect across the y-axis. And then adding 5, we're adding 5 to that whole natural log, which is the whole function, which means there's going to be some kind of vertical change. It's just going to shift the whole thing up 5 units. So the second part is up 5 units. And reflecting across the y-axis and up 5 would be A. Okay, number 28 is pretty easy. It just says we're going to use a calculator, find the log of 0.17. That's literally all you do. Whenever it gives a log though, and there's no base there, remember that's in base 10. So make sure you're in base 10 when you do the log. And log base of 0.17 is negative 0.7696, which would be D. And then the next one says simplify the log. we've got, so this is 10 with an exponent of log of 5. I can rewrite that a little bit. That says 10 log, remember that's base 10 of 5. And when you have bases that are the same, we've got a 10 and a 10, the answer is going to be the same. Okay, had a little technical difficulty there. We'll go back to this. We had 10 log base 10 of 5. Anytime your bases are the same, your answer is just going to be the number you have in the exponent, which is 5. So the answer is B. Number 30 says the results of an analysis on the makeup of garbage, that's exciting, done by the Environmental Protection Agency, was published in 1990. Some of the results are given in the following table, which for various years gives the number of pounds per person per day of various types of waste material. We are only concerned about paper. So there's the paper, and then these are the years. It says for paper, calculate the average rates of change. It's kind of like finding slope. Slope is the difference in the y's over the difference in the x. That's the same as rate of change. So rate of change is going to be like finding slope. We're going to take the difference in the y's over the difference in the x's, and that'll be our rate of change there. So for each one of these, for paper and from 1960 to 1970, we find this difference, 1.19, and then divide it by that 10-year period that they're looking at from 60 to 70. So for this one, the rate of change would be, it's 0.28, but then we're going to divide that by 10, so the rate of change for that one, for that portion, is 0.028. Okay? Then we do the same thing here. Find the difference, 1.32 minus 1.19, divide it by the 10-year period, and its rate of change is 0.013. And then we do the same thing for 1.6 minus 1.32 is also 0.28. And then we divide that by 8 in this case, because the difference between 1988 and 1980 is 8. And that rate of change is 0.035. So that's what we're going to look at to decide those rates right there, to decide what happens. A, the rate of increase stays the same from 1960 through 1980. If all of those numbers were the same, we'd say yes to A, but that's not the case. B, the rate of increase increases during the 70s, but then decreases during the 80s. So from 60 to 7, or from 70 to 80, which that would be the 70s, it's 0.013, but then it has a higher rate of change in the 80s. So that's not what happens. It actually keeps or increases. C, the rate of increase slows down in the 70s, but then increases in the 80s. So in the 60s, it's 0.28, then it is a little bit lower in the 70s, then it's higher again. So that seems like C would probably be the right answer. And then D, the rate of increase slows down during the 60s, but then increases during the 70s and 80s. So no, we have, it goes up, then it goes down a little bit in the 70s, then it comes back up in the 80s. So that's C is the correct answer. All right, number 30, determine the intervals on which the function is increasing, decreasing, and constant. We're just going to follow along our graph. You follow along left to right. So for here, it's obviously decreasing to, it looks like, at -3, and then, or I guess -4. So this would be -4. This is +4. So it's decreasing from -infinity to -4. It's increasing from, looks like 4 to infinity. So it's going up, left to right here. And then constant is where it's level, goes straight across. There's no increase or decrease. And that's happening from -4 to 4. So we just want to see which one has that. It starts with increasing. Increasing was from 4 to infinity. That could be either B or C, but the decreasing is from -infinity to 4, which then that would have to be C there. And the constant is also from -4 to 4 there. So the answer is C for 31. Number 32, we're going to estimate graphically the local maximum and minimum values. So we're looking at like the top of the hill and the bottom of the, you can call it a trough, you can call it a valley, whatever. So we'll go and graph that. All right, so I'm going to graph this equation, and you want to make sure you zoom out so you can see the whole thing. And I have a maximum value at the top here and a minimum value here. So we're looking at our maximum and minimum is going to be our y coordinates. We have a maximum of 7.86 and a minimum at 1, which is A. Number 33 asks whether our function is a one-to-one function. A one-to-one function will pass the vertical line test and the horizontal line test, which means that whether I'm making vertical lines or horizontal lines, it'll only pass through the equation at one point. So since it passes both of those, yes, it is a one-to-one function. Number 34, we want to write the expression in the form bi, where b is a real number. So we're going to write it as an imaginary number. That's because we got the square root of -260. So I'm going to simplify that radical a little bit first. So far I've got negative I square root of 260. And I'm just going to do a factor tree, or also what I call repeated division. It's really the same thing as a factor tree. I'm just going to divide by prime numbers. So I always start with 2. That's 130. Divide by 2 again is 65, sorry. Can't divide by 2 there. I can divide by 5 is 13, and then 5 and 13 are prime numbers. So since 13 is prime, I'm going to stop there. I have 2 to the second, so I only want to group things in groups of 2 because I'm taking the square root. So I've got 2 squared times 5 times 13. I can take the square root of 2 squared as 2, so I can get that out of the radical. But I can't take the square root of 5, I can't take the square root of 13, so I'm going to keep that under the radical and just multiply them back together, which is 65. So this simplifies to -2I square root of 65, which is A.